So let's begin our session 2. So from session 1, we have got this objective function with the surplus variable and artificial variable into the picture. These are called surplus variable and these are called artificial variables. If anybody wants to ask me anything, he or she can raise hand. I'll unmute. I will give you permission to unmute yourself. So so this is the system, and what I was telling in the previous session that the per unit contribution of the artificial variable is always considered to be m, positive quantity m, where m itself is actually a very large quantity and which is positive. But we are using the minus sign, I mean writing minus ma1. That means if during the process the artificial variable retains some value, we want to eliminate the value, we want to eliminate that effect from the objective function, which is actually being denoted by the minus sign, elimination of the effect. But by convention, for some reason, for some mathematical reason, which is beyond the scope of the syllabus, we cannot put the artificial variables per unit contribution to be 0. So it's because of this that this particular simplex method is called big M method. Therefore, it is called big M method. But if there are many artificial variables, for all these artificial variables, we will consider only one M, which will remain fixed. It is not like for A1 we are going to consider M1, for A2 we are going to consider M2, not like this, because these quantities M are so large that you cannot distinguish, at a certain point you cannot distinguish between them two. 1 million and say for example 1 trillion and then 10 trillion, both are too large quantities, both are too large for us. So hypothetically speaking, we can consider them. If I do not consider the numerical value, we just consider that these things are very large. Say for example, you have gone to a forest and you have seen 2 dinosaurs. Both the dinosaurs are very large for you. But their designs are different. So, and once you return from the forest, you're telling me that we have encountered with a dinosaur. Both of you are telling the same thing. So you will say, if I ask you how large it was, you will say very, very large. You have not measured it, but you very, so mera bhi bahut bada, bahut ferocious tha, dangerous tha, bahut bada tha. Or the other boy will also say that, yeah, mine was also very too large, and yeah, nobody has measured. So something when it is not measured, how large it is, we say that very, very large. So for artificial variables, contribution is very, very large quantity. Artificial variable 2's contribution is very, very large quantity, and therefore we are going to put M for both of them. Now we are in a position to construct the simplex table. So simplex table 1. And you know that the process is so tedious. So anyways, you have to bear with it. First of all, as I told you in my previous session, that you need to consider the format. So what is the format? Format is this. And we are going to write minimum positive ratio XB by pivot column. And below that, we are going to write ZJ and ZJ minus CJ. This is the format. And you know what to do next. We are going to put all the variables over here. X, Y, S1, S2, A1, A2, serially. And their per unit contributions are considered from the objective function, and they are put over here on the top. These are the per unit contributions of the objective function. What are the basic variables? The basic variables are A1 and A2. So we are going to put A1 and A2, and the first value of the basic variable was 0, second value was 2. We are going to put it in the XB column. The per unit contribution of the artificial variable into the system is minus m, and these are the basic variables, and CB means CB is a part of CJ. CB is the per unit contribution of the basic variables. So we are going to write minus m and minus m here. And then we are going to put it in a matrix way. The coefficients, first of all, you mark the coefficients. The coefficient of x is 1, coefficient of y is -1, coefficient of S1 is -1, coefficient of A1 is 1, coefficient of x is -2, coefficient of y is -1, coefficient of S2 is -1, coefficient of A2 is +1. We are going to put them all. So we are going to write here 1, -1, -1, S2 is not present, so it is 0, 1, A2 is not present, so it is 0. Second row means second equation, -2, -1, 0, because S1 is not present, minus S2 means -1, 0, 1. And you know how to calculate ZJ. The formula of calculating ZJ is CBT x J. This is the formula. I'm not going to discuss in details because many a times I discussed in the previous session. So we are actually going to multiply. I'm showing you only one. If I'm going to calculate the Z1 means for the, or ZX, for the X column, it would be CBT into X, means minus M, column matrix will become row matrix because transpose is taken, multiplied by 1 and -2, which will be minus M minus twice M. Okay, in this manner, that is minus 3M. In this manner, we are going to calculate the other ZJs also. So we are going to put the values minus M minus, oh, it would be, sorry, it would be not, it is -2 though, -2, that means minus M, and that is also minus M, sorry, this is minus M. So minus M into -1, that is minus M, minus M into -2, that is +2M. So that would be just M, not -3M, M. Okay, so so we are going to write over here minus M into 1 and +2M, that is M. Second one will be minus M into 1 plus minus M into -1, that is M, and that is minus M. I mean, let me write it over here. I can also make some errors. So that would be minus M into -1, so that would be plus M, which is twice M. So this is twice M. Okay. Next one is minus M into -1, so that is M. Then because minus M into 0 is 0. Fourth one is minus M into 0 plus this into this, so it is M. Next one is minus M into 1 plus this into 0, that is minus M. Next one is also minus M. Okay, and ZJ minus CJ means you are going to subtract CJ from this ZJ. You are going to subtract this CJ from this ZJ, and so on. So for the first one, we are going to get M minus 1. For the second one, we are going to get twice M minus 1. For the next one, you are going to get M. then m, then minus m minus minus m, that is plus m, that is 0, minus m minus minus m, that is plus m, that is 0. Okay. Now, as I can see that you are very lucky to have this problem, and I am also very, I mean some sort of burden has been removed from my heart because of carrying out calculation of this particular simplex table. Why is it so? Because you see, as I already told you, since, okay, just a minute, someone wants to ask me something. Okay. Ask, what do you want to know, Upama?
স্যার বলছি যে জেড জে মাইনাস সি জে লাইনটা আরেকবার একটু বলবেন কি করে হলো?
আচ্ছা, জেড জে হচ্ছে গিয়ে তোমার, ধরো আমি ক্যালকুলেশন করতে চাই z1, if I want to calculate z1, z1 means z1 minus c1, z1 minus c1 means z1 is m, this is m, this is your m, and c1 means this one, so m minus 1, that is m minus 1. It's just simple subtraction.
আচ্ছা আচ্ছা,
okay,
z1 এর থেকে c1 উপরের লাইনটাকে টোটালি মাইনাস করব, তাই তো, একটা একটা করে?
exactly corresponding values will be subtracted from the zj.
আচ্ছা আচ্ছা,
next,
ঠিক আছে
সুমন্ত।
স্যার ওই ম্যাক্স জেড এর যে ইকুয়েশনটা আছে ওখানে যখন আপনি s1 s2 টা বসালেন তো তখন তো ওটা 0 দিয়ে বসিয়েছিলেন যাতে s1 s2 টা কোনো ফাংশন না করে, কিন্তু m টা যখন বসিয়েছেন তখন তো ওটা ফাংশন করবে কারণ m এর মান তো 0 হবে না,
রাইট ইউ
তো ওটা আমি এক্সট্রা যখন এনেছি তো ওটা তো এক্সট্রা আনা মানে কোনো ইকুয়েশনে এক্সট্রা আনা মানে সেটাকে তো তাহলে আমাকে কিছু ভাবে ওটাকে মানে কাটাতে হবে।
Yes, now you are going to, you have asked me the right question, so you are going to get to know that you are going to get the reply from the problem itself. Now just let me finish the problem and I am going to give you a reply. So first of all, since m is greater than 0, so therefore obviously m minus 1, m is a very large quantity, so m minus 1 is also a positive quantity and twice m minus 1 is also a positive quantity. Now don't say that sir, m greater than 0, therefore m minus 1 will be greater than minus 1 like this. I am not doing algebra over here. I am just telling you the nature of m. The nature of m is what? The nature of m is positive, so obviously for a very large quantity you are subtracting something unit amount, so it will be also positive. Twice m minus 1 is naturally it will be positive. So this is what I'm talking about, the nature of the quantities. I'm not doing the algebra. Don't think that I am subtracting minus 1 from the left hand side and not from the right hand side. This is not I'm doing over here. M is a very large quantity and we are subtracting from minus 1 unit quantity. It will be a positive quantity. Twice m minus 1 will also be a positive quantity. Okay, so you see that in zj minus cj row, this is a positive quantity, this is a positive quantity, this is by nature is a positive quantity, this is a positive quantity, this is 0, this is 0. So therefore this is positive, positive, 0, 0. And I told in my last class that if zj minus cj contains all the non-negative values, you have reached your optimal solution. So the happy moment is that we don't have to deal with any more simplex table for this particular problem because we have reached our optimality. we have reached our optimality. So we will note it down over here first of all. I'm feeling relaxed. We don't have to do anything else for this particular problem. So let me write the conclusion first of all. Since in this simplex table 1, all the elements of Zj minus Cj row are non-negative. So optimal solution is reached, and we don't have to construct any more simplex table, We don't have to construct any more simplex table. Okay, but now I am coming to the question that Shumanta has asked. Shumanta has asked that so far you have discussed in the simplex table methodology that whenever we introduce some variables like slack or surplus, we put per unit contribution 0 so that it shouldn't affect the objective function. But for some reason or other, which hasn't been discussed mathematically in the class, we have put some positive quantity as a per unit contribution to the objective function for the variables a1 and a2, which are artificial variables, with a preceding minus sign. Now, Shumanta's question is, this is in contrast to what you have told in the previous class. If I do so, if I put this kind of thing, so artificial variable will remain. As you can see that here, artificial variable a2 is attaining the value 2. And here artificial variable is getting removed because it is 0. So it is not always the case that artificial variable will be having the value 0. It may have also non-zero value. So now if I put them in the system, okay, then the objective function is getting changed. So it is in contrast to what you have told us in the previous sessions. Now here is the catch. Since for some reason or other we are unable to put the per unit contribution of the artificial variable as 0 in the objective function, our basic objective will remain to remove the artificial variable from the basis. We always try to remove the artificial variable from the basis. We always try to get 0 value for the artificial variables. If this way, if not this way, then that way. If its per unit contribution is not 0, make it 0. Then objective function will not be affected. Okay, so if the per unit contribution of a1 is not 0, per unit contribution of a2 is not 0, make a1 0 and a2 0. Then put the 0 values in the objective function and you say that, okay, now it is all right. My objective function is not getting affected. But right now you will tell me, you will ask me that it is not happening in this case. You are not able to do any more simplex table because the indicator has already told you that you have to stop. Optimality is reached. So how can you do so? How can you make it a 0? Okay, we understand that a1 is 0, but how will you be able to make it 0 for a2? The answer is we will not be able to, and therefore, since artificial variable is present with non-zero values or zero values in the basis at the optimality stage so the system has infeasible solution. The system has infeasible solution. That's why the system has infeasible solution. Since we are not able to remove them from the basis, we want to do the process in such a way. We expect the thing to work in the following manner, that the simplex process is going on. Simplex process is going on, and at that stage, we're going to at the optimality stage, we're going to something in the basis other than the artificial variable. This is our expectation. But if artificial variable is retained in the basis of the simplex table at the optimality stage, that means you are not able to make them zero. You are not able to remove them from the basis. At this type of thing, at this point, we'll say that the system has no feasible solution. And you already know that was happening for this particular problem when we draw the graph. The artificial variable, okay, the region, if you draw the graph correctly, the region will be falling in the third quadrant. So that was happening. Okay, so this is the answer to your question, Sumanto. Have you understood?
Yes, sir.
Okay, this is the answer to your question. So this is an important note that this is an important point that you need to note down, that if the artificial variable is not removed from the basis, then we cannot say that the system has infeasible solution. Feasible solution. Okay. Now the
Sir, can
yes.
you go back to the previous page once?
Yes.
Okay,
Now
thank you, sir.
let me talk about
Sir.
yes, tell me.
স্যার আর্টিফিশিয়াল এটা কখন ইকুয়েশনের জন্য কখন আমাদের লাগবে কি করে বুঝবো?
Whenever there is
আর্টিফিশিয়াল এটা লাগেনি।
I said in the previous session, whenever there is a greater than type of inequality, and whenever there is you use the surplus variable to make the greater than inequality as balanced, as equality, every surplus variable is associated with the artificial variable. Whenever in an equation, whenever in a constraint there is a greater than type of inequality, you always get to know that there will be an artificial variable, because there will be a surplus variable, and every surplus variable will be associated with an artificial variable. If the system has no greater than type of inequality, then there will be no surplus variable and no artificial variable at all.
আর অলওয়েজ আর্টিফিশিয়াল ভেরিয়েবল আসলে সেটা মাইনাস সাইনেই বসবে।
Artificial variable objective function, in the objective function it will be put as minus m. It will be its per unit contribution will be minus m, but it will be added in the constraint. It will not be subtracted from the constraint. Understood?
Yes, sir. Yes, sir.
Okay. Now, okay. Now you see, I'm going to give you a problem. No, you don't have to do it by now, by yourself. I'm just writing the problem. Minimize z minus 2x1 plus x2 subject to x1 plus x2 greater than or equal to 6, 3x1 plus 2x2 greater than or equal to 16, x2 less than or equal to 9, x1, x2 greater than or equal to 0. Now this particular problem, first of all, later you can check graphically what is the solution for the problem. Graphical checking is always recommended if the number of variable is 2. So I am leaving it for you to check by yourself. And you are going to tell me, what do you think? Will there be slack variable or surplus variable in the system? Just now you have asked me how to understand that whether the system will be having artificial variable or not. So can you tell me what will be the change? What will be the changed system with respect to this? First of all, I'm asking about the constraints. Tell me one by one, what will be the change in the constraints? Tell me how to change the constraints.
So I
First-
think we have to.
Well, one by one. First of all, you can talk. Let's talk about this. What will I write? I want to change this particular inequality first of all. What will I write?
Sir, x1 plus x2
x1 plus x2
plus s1.
No. Greater than.
So x1 plus x2 minus s1.
What is s1? What is s1?
S1 is a slack variable.
No.
Oh, sorry,
Surplus
surplus variable.
Surplus. Okay. Minus s1 then.
Plus a1.
Yes. Plus a1. Always a surplus variable is associated with the artificial variable. So it is 6. Okay. What about the now let's talk about the next one.
3x1
plus
plus
2x2
2x2 minus s2.
plus s2 plus a2.
Yeah, that is s2 is also a surplus variable plus a2, which is equal to 16. Let's talk about that one.
x2
So I think x2 minus s3
What is
plus
this?
a2.
What is this
Plus.
inequality? Plus
Plus
s3. S3. What is this variable?
This is also a surplus, I think.
No.
minus a3.
This is slack. Lesser than type inequality. This is greater than and this is lesser than. Slack will not be associated with any artificial variable. Slack is when slack is added, just it is added. It will not be given and it will not be associated with any artificial variable. Remember,
Equals to 9.
equals to 9. That's it. That's it. Now, see, the problem is a minimization type of problem. I told you that simplex method is designed in such a way so that it is only valid for the maximization type of problems. So what we need to do is that there is a formula, there's a theorem. The theorem says that if there is a minimization type of problem, first of all, you convert it into a maximization type of problem. Okay. If there is a minimization, type of problem, convert it into a maximization type. Convert it into a maximization type. Okay, and the theorem is min z is equal to minus of max of minus z. This is a very well-known theorem. Min z equal to minus of max of minus z. So in objective function, this is a minimization type of objective function. So here I will not able to write it just the way I wrote in the previous case. I cannot write minimize z equal to this and starts doing simplex. First of all, you need to do a little bit of thing over here. Conversion part. The conversion part is that you write z as minus z, multiply z by -1 from both sides. So you get minus z on the left hand side, 2x1 minus x2 on the right hand side. Okay, and here we'll write max of this. This is the conversion. Rest will remain same. The other constraints will not have to do anything with this. They will remain as it is because they are separate entities. Okay, so it is not going to affect the constraints, don't worry. But because of this rule, we are going to convert z into minus z. Minimize z will become max of minus z. Remember, don't forget about this minus sign. Why? Because once you solve the problem, you probably will get a negative value for minus z. That negative value will be made positive with a preceding minus sign. It will be effective at the end of the problem, not in the beginning of the problem. It will be effective in the end of the problem. So we will treat this as our objective function, not that for the time being, because we want to do the simplex. Rest is same. We are going to make it as max of minus z. Let us give it a name. We can call it as max of w. Okay, if you have any problem with minus z, you can put w and give it another name, so w. Max of w. So the problem has become maximization type of problem. 2x1 minus x2, and then you put the contributions of the slack and the surplus in the objective function. So s1 is there. We will write plus 0 into s1. s2 is there. We will write plus 0 into s2. a1 is there. We will write minus m into a1. a2 is there. We will write minus m into a2. Only there is a change at this point because it is a minimization type of problem. So we have converted that into a maximization type of problem. Understood? And the number of variables x1, x2, s1, s2, a1, a2, this would be greater than or equal to 0. Okay, this would be greater than or equal to 0. And now you tell me how many variables are there. Number of variables present here is, tell me. How many?
6.
6.
Sir,
Yeah.
sir,
Yes.
S3 আসবে না স্যার?
ও হ্যাঁ, S3 আসবে তো। এগুলো তো তুমি জানো, এগুলো আমার সিলি মিস্টেক। তো আমিও তো মানে সিলি মিস্টেক করতে পারি নাকি? আমি একটু সিলি মিস্টেক করলাম, তোমরা একটু ভুলটা ধরলে, এটা বেশ ভালো। এটা এই তুমি করলে, আমাকে বললে S3 টা, আমি খুশি হলাম। তো মনোযোগ দিয়ে করছো, খুব ভালো, গুড গার্ল। আর এইবার নাম্বার অফ ইকুয়েশন, হাউ মেনি ইকুয়েশনস আর দেয়ার?
স্যার নাম্বার অফ ভেরিয়েবলস এর 7টা হবে স্যার।
7টা হবে। এই যে গুড বয়, খুব ভালো, খুশি হচ্ছে খুব আমি। 7টা হবে তাহলে। এই কালার চেক চুজ করতে করতে জান বেরিয়ে যাচ্ছে, এটা গেল কোথায়? এই যে Chatta. How many equations?
3, sir.
So number of non-basic variable. Number
স্যার
of
4টে
7 minus 3 equal to 4. And now you tell me which one you are going to consider to be non-basic with the convention. Which one? Which 4? Apply the convention. Quickly, time is running out. Which 4 you are going to consider non-basic? 7 variables are there. Which 4? Original slack surplus artificial. Original slack surplus artificial.
x1 x2 s1 s2
Original, sorry. Rhyme is a little bit changed. Initially, I told you the rhyme in a wrong manner. So some sequence will change. Not original slack surplus artificial.
ভয়েসটা ব্লেক করে আসছে
Original surplus slack artificial. That should be the pattern. Original surplus will come first before slack. Artificial. Why is it so? Okay, two original variables x1 and x2 will be put 0. But if I take slack first of all, if I take s3 equal to 0, so x1 0, x2 0, s3 0, so that will become 0 equal to 9. So this is a change. I mean, here in the previous case also, I will, if I upload the video in the YouTube, I will put a note over there that the pattern will be original surplus slack artificial. If you have noted it down somewhere, just rectify that. Original surplus slack artificial. So first of all, we will put x1 equal to 0, x2 equal to 0. If I put slack equal to 0, then it will become 0 equal to 9, which is absurd. So we will put s1 equal to 0 and s2 equal to 0. All these variables will be non-basic variables. And the basic variables will be a1
S3 A1 A2.
A1 is 6, A2 is 16, S3 is equal to 9. Now at this point I'm stopping for our today's class. You just try to solve this problem by simplex as well as graphical. If you have faced any trouble, you let me know. I will help you out. Okay. So you don't have to join once again. I'm ending the class at this point. It's a homework for you. Homework for you. Yeah.
Sir, attendance